Hi everybody, and welcome back to our discussion on Chapter 9 about power. So we just spent a very extensive amount of time discussing strength, and now it's time to talk about that specialized strength in the form of power. So, by definition, power is an applied force multiplied by the velocity of the movement. We can also talk about this as work done per unit of time. So it is going to be a discussion of not only your strength, but how quickly can you apply that strength. Power we tend to measure in watts when we are doing the actual mathematical calculations. Standard power output for athletes can range anywhere from 50 watts to 7,000 watts. So if you need to think about that in wattage that we would use in a home, 50 watts is about what you need to power a standard light bulb. Most are 60 to 120. And 7,000 watts is the energy that can run all the electricity in your house for a day. So some athletes are capable of producing huge amounts of power very, very quickly. So why does this actually matter for physical activity, sports, and athletics? Well, maximum power output is the main determinant of our performance in activities that require one movement sequence with the goal of producing high velocity at release or impact. So what does that actually mean? Basically, power output is the determining factor when we are dealing with throwing, jumping, or striking activities. So if you think about it, most sports are going to involve some sort of throw, some sort of jump, or some sort of strike. Any sports that don't require this are going to be more important either for endurance or strength. Power output is also important if we're going to change directions. So anything that requires an acceleration, then a deceleration, or a change of direction. So think about any sport that involves a cutting movement. Power output is going to be important because it is controlled speed change. This means that the mechanical properties of our body, particularly the neuromuscular system, are going to be our limiting factors for performance. So if we look over here to our left, we have a couple different things going on. One of them is the maximum rate of force development, also known as MRFD. So that is how quickly can you develop force. So we can see this here at takeoff. So this big peak with kind of the dash dot combination line. Basically, our maximal rate of force development is our ability to produce high force at the end of an eccentric contraction. So we get a big stretch, and then we convert all of that energy stored in the stretch into an explosive concentric movement. So here we can see the start of our force plate. We are absorbing energy in the eccentric phase and then quickly converting this into power output in the form of velocity. This transition between eccentric and concentric activity is referred to as the amortization phase. We want this to be as low or as small as possible for optimal force development. This also, with maximal force development, is our ability to continue to produce high levels of contraction once a muscle is shortened. So I'm contracting a muscle. What is my ability to continue to contract my muscle? So what is going to contribute to maximal power output? Well, we have either intracellular factors or neural factors. Intracellular factors are going to be mostly the maximal rate of cross-bridge cycling. This is just kind of determined for everybody. And then the total quantity of our microfilaments. There is some genetic component to this, and there is some component that comes with training. We can also see over here to the left some other factors with the cross-sectional area, basically how your muscle is structured, how much energy is available. So we know from just kind of studies in exercise physiology that we are going to need lots of anaerobic respiration, so carbohydrate breakdown for power output, and then what muscle fiber type is being utilized. We also have to consider our neural factors. So how is our nervous system going to work to develop power output? So if we want to produce high amounts of power, our agonist muscles must be fully activated. So we have to get a very good, strong nerve signal to these. And our synergists, which are our helpers, and our antagonists need to be appropriately activated. So those muscles that run counter in terms of the antagonist have to provide a stable base for us to push off of for our agonist muscles, and our synergists have to be in good locations for support. Anytime we're going to have overactivation of an antagonist or a synergist muscle, we are going to decrease our power output. So, other things we need to consider with contributing to power output. First is the stretch shortening cycle. This is what we particularly train in plyometric training. Basically, this is anytime we have an eccentric loading phase to an amortization phase to a concentric muscular contraction. Or another way to think about this is a counter movement transitioning into the actual movement I want. So during the counter movement, we're going to stretch those muscles eccentrically, and it's going to store up energy, and then we're going to transfer that energy through the amortization phase into concentric muscular contraction. And as I said, this is done using plyometric style training. I can also get some changes in power output with muscular strength and heavy resistance training. So as we talked about in the last lecture, any improvements in your overall maximal strength, even at a slow velocity, is going to contribute to your maximal power. Think of it as you're building up the engine. So the bigger the engine, the more our power output, even if it's not training for power output specifically. Also, another consideration is that even though we've documented improvements in power output with muscular strength and heavy resistance training, we still need to have some sort of specific power training to get our most effective results. So this kind of brings us to the point of we need to integrate our training for power. So we know training with slow velocity, heavy resistance has the potential to improve maximal power output and power development. So remember, strength training allows us to build a bigger engine, and bigger engines tend to have more power. We need to also train the body with the force and the velocity components to improve our power performance. So if I need you to be able to do a pushing motion quickly, yes, I could crank up your bench press to ridiculous numbers, but I also need to teach you how to move quickly. Any activity where the athlete attempts to generate force rapidly is going to increase the ability to do that again better than any high level of resistance training. So we can see over here, we have maximal rate of force development as kind of this longer dashed line. And when we start comparing untrained and then light resistance training and heavy resistance training, we notice that heavy resistance training can make the force development bigger, but our maximal strength and maximal power output are all happening at kind of the same point, and our lighter resistance power training is going to give us the most bang for our buck. All right, so another specialized type of plyometric training and power training is something referred to as ballistic training. So this is going to require the resistance to be projected into free space at a high velocity. So ballistic resistance training is basically throwing. There's no optimal intensity or resistance, since both heavy and light resistances are going to help with power development. But if you have to make a choice, somewhere around 30% of maximal voluntary contraction tends to be our ideal ballistic training. So if I'm actually going to have to project something or throw something, what am I talking about? You can throw a med ball, you can throw weighted clubs. Any of our landmine exercises can be thought of this. Obviously, we don't let go of a bar when we're doing a landmine exercise, but we're being explosive through that entire range of motion. You can also think about this as a clean pull. We pull the movement and then we intentionally let go before the catch. Strength increases are going to be specific to the velocity at which one trains. So this is why we say about 30% maximal voluntary contraction, because it's kind of the optimal spot to get the fastest contraction. The only downside of ballistic training really is that we have a large force placed on the athlete if you have to then catch whatever was launched. Or Ballistically, putting your body through space can be thought of as ballistic resistance training. If you're a larger individual, having to continually catch your body weight can be damaging. So we have to be very smart about when and how we utilize ballistic resistance training. We also need to appropriately progress these exercises from unloaded to loaded conditions. So anytime you're doing a high intensity plyometric training exercise, your athlete should be able to squat about 1.5 times their body weight. This is a very debated recommendation. This is kind of an arbitrary number that strength coaches like to use to be like, oh, we shouldn't do plyometric training until they can do this. But, good rule of thumb, but not always very practical. The next consideration is kind of something called the window of adaptation. So kind of digging into that 1.5 times your body weight recommendation and why sometimes it's a good one and sometimes it's not. So plyometric training alone has been found to be effective for increasing power performance, while traditional resistance training has been shown to either slightly increase or pretty much have no result. So if we know plyometric training is the way to go, why wouldn't we go into it? Well, it's that damaging aspect. If somebody's not strong enough to handle it, we can hurt them. However, if we can take plyometrics and resistance training and combine them effectively, power performance is going to increase in a much more effective, efficient, and safe manner. So we have a couple different things that we can pull on. And the components are called the windows of adaptation, meaning that each component of power training gets stronger, it's going to become less effective at eliciting change. So if we look over here to the left, we have slow velocity strength. This is one of the safest ways to train somebody. But then eventually I'm going to get strong and it's going to stop being a good lever. So I'm going to have to switch to something else. So high velocity strength, or maybe we focus on the rate of force development. This is where we can start doing like speed work with a barbell, or we can start talking about these plyometric exercises. And then you start pulling all of these together until eventually you get to a full realized training plan. So ideally we would like a little bit of both, and then kind of working through each window as we can to get the most change out of our athletes' performance. All right, so now that we kind of have a working understanding of power and its importance, we need to talk about how do we actually assess this in a weight room or under coaching conditions. To properly assess muscular power, we have to define our characteristics that we are going to study. So, are we looking at neuromuscular performance qualities? So these are genetics and sports demands. Well, the genetics one is kind of unfair because you're born with that one, but we can start looking at sport demands. What is going to be required for the sport in terms of strength, speed strength, reactive strength, stretch shortening cycle, and power endurance? So once we know what we need kind of from the sport, then we can start looking at performance diagnosis and prescription. So we determine what is an important quality of the target activity we're trying to measure. And we need to pick something that is going to frequently occur in the sport or is ongoing in the sport so it makes sense to be measured. We're then going to take that particular target activity or movement we want to look at and find its key performance characteristics. Once we've broken that down, we can do a biomechanical analysis and decide kind of what do we want to assess. So one way we can assess power performance, if you have money and a lab, we can do things like force plates and linear position transducers, and we can have you jump on the force plate and get how much actual force is being put into the ground whenever you do a particular movement. So if you have velocity-based training, a force plate, we can do some of this with a jump mat. If you've done any assessing in our weight room here at Newberry, these are great activities and equipment to use. However, they're expensive and not very practical for the real world. So we need to think of some other ways that we can assess power performance. All right. So one way we can do this is we can sort of hint around power performance. We can assess these things very easily. For example, maximum strength. if I want to know something about somebody's power, maybe I do the maximal strength of a power clean or a snatch, or I do a vert jump or a broad jump. If I want to know about high load speed strength, this would be something like, sorry, I lost my train of thought. High load speed strength would be like how hard can you hit a tackling dummy at football practice? Or if I give you a two-step start, how far can you push the tackling dummy until you kind of burn out? Low speed strength, these are things more like a bench press max or a squat max. Looking at the rate of force development, we can do all sorts of bounding drills, or I can ask you to do 3 broad jumps in a row. And then things like reactive strength are box jumps, and then skills performance, we're just kind of looking at your technique and your ability to do a drill in a particular sport. So, wrapping all of this up, we've kind of talked about the importance of power, how do we look at it, how do we assess it, how do we train it? And now we're going to look at how we train it. So usually to assess and train power, we want to either do very heavy resistance training, which we know works, but it's low speed strength. So we're building the engine and it's not necessarily best. We can do ballistic resistance training, which is leading into plyometrics. Very, very helpful, but we need to be careful at how much we're doing so we don't overload or damage our athletes. And then the best combination is weightlifting with those heavy resistance training programs, with the ballistic, and getting the hybrid results. So I hope this has been informative. This was a nice, short, sweet chapter. And if you have any questions, please let me know. Look forward to seeing you all in chapter